On July 12, 2022, NASA released a photograph. It was taken in a tiny patch of sky, about the size of a grain of sand held at arm's length. In that speck of nothing, James Webb found thousands of galaxies. Some of them formed less than a billion years after the Big Bang. We had never seen them before. We couldn't. And that image was just the beginning. 25 years, $10 billion. It almost didn't happen. 3 times. James Webb launched on Christmas Day 2021. It flew to a point 1.5 million kilometers from Earth. It unfolded a mirror the size of a tennis court. It cooled to 40 degrees above absolute zero. Then it opened its eye. What it saw in the first week broke every record. What it found in the months after broke our models. This is what happened. July 11th, 2022. President Biden stood at the White House and unveiled a single photograph. It looked like something from science fiction. Thousands of galaxies packed into a region of sky, barely larger than a grain of sand. Galaxy clusters bending the fabric of space-time, stretching and warping the light from more distant galaxies behind them into glowing arcs. That smeared arc you're looking at? That's not one galaxy. That's the same galaxy, repeated 3 times. Its light bent and multiplied by the gravity of an entire cluster sitting between us and it. The light from some of those galaxies left before our solar system existed. Before Earth was even dust. James Webb caught it. Every single dot in that image is a galaxy, not a star, a galaxy, containing hundreds of billions of stars. This was the deepest infrared image of the universe ever captured. And it was released on day 1. To understand how extraordinary Webb is, you have to understand the road that almost killed it. The story starts in 1996. Hubble was already in orbit, revolutionizing astronomy. But scientists knew its limits. Hubble sees invisible light, the same light your eyes see. But the universe hides most of its history in wavelengths we can't see. So astronomers proposed the Next Generation Space Telescope. The original budget estimate, $500 million. The original launch date, 2007. What actually happened, 25 years of delays, 3 near cancellations by Congress, a global pandemic, and a final cost, more than 20 times the original estimate. At one point in 2011, the House of Representatives voted to cancel it entirely. It survived by a narrow margin. More than 10,000 people worked on it. Some spent their entire careers, decades, without seeing it fly. Then, on December 25th, 2021, it launched. And nothing went wrong. Not a single thing, which was almost more shocking than anything Webb would later photograph. James Webb doesn't see the universe the way your eyes do. It sees in infrared, light waves longer than visible red, completely invisible to human vision. And that's not a limitation, it's the whole point. There are 2 reasons infrared is the right tool for looking at the early universe. First, dust. The most interesting things in the cosmos, star formation, galaxy cores, planetary nurseries, are all buried in clouds of gas and dust that block visible light completely. Infrared passes right through for light redshift. The universe is expanding. As light travels across billions of light years, the expansion of space stretches its wavelength, shifting it from visible or ultraviolet into infrared. The farther the galaxy, the more redshifted its light. To see the very first galaxies, you need an infrared telescope. But Webb didn't just point at the right wavelengths. It was engineered to see them with almost impossible precision. Its primary mirror is 6.5 meters across, nearly 3 times Hubble's collecting area. It operates at minus 233 degrees Celsius. That's colder than Pluto. Because infrared is essentially heat radiation. If the telescope were warm, it would blind itself with its own glow. On July 12th, 2022, the day after Biden's preview, NASA released 5 images simultaneously. Each one was a statement. SMACS. 723. The deep field we already discussed. Thousands of galaxies, gravitational lensing. The deepest infrared image ever taken. That's what Hubble saw. That's what Webb saw. Same patch of sky. But where Hubble saw a handful of faint smudges after days of exposure, Webb revealed the structure of entire galaxies in 12.5 hours. Stephan's quintet, 5 galaxies caught in a trillion-year collision. Webb showed an intergalactic shock wave, a wave of hot gas, 380 billion kilometers wide, in unprecedented detail. The Southern Ring Nebula, a dying star shedding its outer layers. Webb found a second star in the center, a companion that was shaping the nebula's structure all along. Hubble had missed it. The Carina Nebula. Webb revealed hundreds of previously unseen young stars forming in the cosmic cliffs, protostars still wrapped in their birth clouds, invisible to every telescope that came before. And then, the spectrum of WASP 96b, an exoplanet 700 light-years away. In a single graph, Webb detected water vapor, haze, and clouds in its atmosphere. For the first time, directly. All 5 on the same day. Here's a number that should stop you in your tracks. The universe is 13.8 billion years old. James Webb is now routinely photographing galaxies that formed when the universe was less than 500 million years old. That's not just old. That's the first chapter of cosmic history, the period when the very first galaxies were assembling out of hydrogen gas, when the first stars ignited, when the universe went from dark to lit. The JD's survey, using Webb's deep field data, found galaxies at redshifts above 10. That means the universe was less than 450 million years old when their light left. In June 2024, astronomers confirmed the most distant galaxy ever observed, JADE's GS Z14-0. It existed just 290 million years after the Big Bang. And here's the thing that keeps astronomers up at night. These early galaxies are too big, too bright, too massive for their age. The standard model of galaxy formation, our best theory, didn't predict galaxies this large this early. Webb is not just confirming what we knew, it's finding things that break our models. And that's exactly what you want from a telescope. In part 2, we'll see Webb turn towards stellar nurseries, alien atmospheres, and the search for life itself. The telescope is already out there. It's already looking. Subscribe so you don't miss what it finds.